Noswaith dda. Good evening and welcome to all of you online. Thank you for joining us. I'm Professor Steve Riley, Pro-Vice Chancellor for the College of Biomedical and Life Sciences here at Cardiff University. You're here this evening as part of the Cardiff community, including alumni, staff, donors and friends who are supporting the university. And tonight's event will be recorded and you'll receive a link afterwards, which you're welcome to share. This evening's talk features research based in the university's Systems Immunity Research Institute. We established this interdisciplinary group of researchers to investigate the role of the immune system, that the immune system plays in acute and chronic diseases, working to understand the complex way the immune system keeps us healthy, but also what happens when its normal function is affected and changed, and we see that the body's immune system attacking itself. Our aim at the Research Institute is to investigate and learn about the underlying mechanisms and functions of the immune system so that we may develop clinical practices for early and accurate diagnosis and effective treatments that have direct implications for patients across the world. Tonight's talk is about type 1 diabetes, an autoimmune condition, one where the body's own defense system attacks particular cells in the pancreas. A diagnosis of this lifelong condition will have significant impact onto a person's life, and so one where early and accurate diagnosis is important. If we can find people who are at risk of the condition before they develop it, then that too is really significant. So I'm delighted to introduce our speakers this evening who are investigating this topic area. They are Dr. James Pearson, who is a research fellow at the School of Medicine, and his colleague, Katie Boest-Bjerg, who is a PhD student and research technician based in James's laboratory. They are both Cardiff alumni, Katie graduating with a BSc and James awarded his doctorate here at Cardiff. They will be sharing their research and its impact with us, and as ever, we'll answer your live questions this evening. Please enter them in the Q&A box at the bottom of your screen, and we will answer as many as time permits. But for now, I'm delighted to ask Katie, followed by James, to present. Welcome and croeso. Welcome to you both. We are delighted to have you present your work. Katie, I believe you'll be speaking first.
Yes, thank you. Okay, can we all see this? Okay, perfect. Yes, so James and I are going to talk about this project we've been working on. So it's time of day influences autoantibodies in people with type 1 diabetes. So these autoantibodies are proteins which are made by the immune system. So the immune system, it's the body's defense system. It's made up of various cells, tissues, and organs. And what happens is that the immune system will recognize a harmful germ, such as a bacteria or a virus. It sends different immune cells to attack this, and it will destroy the germ. It then also creates memory cells, which can respond faster if the same germ returns. So type 1 diabetes. So it's different to type 2 diabetes. This is very important. So what happens in people who live with type 1 diabetes is that their own immune system will attack the insulin-producing cells in the pancreas, and these are called beta cells. It's a lifelong condition, and because these insulin-producing cells are damaged, people living with this condition need to administer insulin every day to survive. Currently in the UK, there's at least 400,000 people who live with this condition, and each year more and more people are being diagnosed. So what we need to know is who is at risk of developing this condition. So what we have here is a big insulin-producing cell, and these are the ones that are found in the pancreas. So when the damage occurs, all these proteins that are found inside the cell come outside the cell. And these cells are not harmful, but the people who live with type 1 diabetes, their autoantibodies will recognize these proteins. These are now labeled as bad, and so the immune system will further target these insulin-producing cells. Even though this damage occurs in the pancreas, what we can do is through a simple blood test in the arm, we can find out if someone has any of these autoantibodies or not. So why are these important in type 1 diabetes? So what we have here is a study And it looked at over 10,000 children, and they followed them from when they were born till they were 20 years old. And what we have up here is the probability of one of these people developing type 1 diabetes. So down here, we've got quite a low chance and then quite a high chance. And when they looked at the blood of all these people, they found that if a person had no autoantibodies or only one of those antibodies, they had quite a low chance of developing the disease compared to those who had 2 autoantibodies or 3 autoantibodies. And you can see they had quite a high chance of developing it. So we want to know how we can further improve autoantibody measurements. So what our lab was really interested in are these body clocks or circadian rhythms. So basically they influence every single thing in our body. So every single cell is affected by the time of day. So it's either, if it's in the middle of the day, the light enters our body and it tells us it's the middle of the day, this is when we're eating, there's more brain activity, whereas at night we're more in a rest phase. So what we know from different studies is that the time of day can alter antibody responses. So these different studies gave the vaccines to influenza, TB, and the COVID-19. And what they did was they found that when they gave the vaccine in the morning, there was a boosted antibody response to those who received the evening or afternoon vaccine. Crucially, all 3 vaccines worked at any time of day. It's just those who got them in the morning, we saw a boosted response. So we thought, okay, what about type 1 diabetes? So what we did was we wanted to investigate whether the autoantibodies in people with type 1 diabetes, and we think that the time of day affects autoantibodies in the people who are living with this condition. So James is now going to explain some of the research we've been doing.
Thank you very much, Katie. So as Katie mentioned, we've been interested in measuring these autoantibodies in the context of type 1 diabetes. And to do this, we had to study a number of individuals with type 1 diabetes, and we collected 6 blood samples from these people. The first one collected at 9 AM, and then we collected blood samples every 4 hours over a 24-hour period from these same people. We then measured these autoantibodies that were related to type 1 diabetes that Katie introduced, these antibodies to insulin, i.e. to GAD or ZNTA. And then we had to work out whether the time of day actually made a difference. Did we see these ups and downs as shown here on the graph in those autoantibody levels? So what we found when we did this experiment was actually that 3 of these different autoantibodies, so insulin, ZNTA, and IA2 shown here, the majority of people had their peak, so when their antibody levels were highest, actually in the morning. And you can see this in this yellow part of this pie chart. So you can see that 85% of people had their highest level of insulin autoantibodies in the morning, 70% had the highest levels of ZNTA autoantibodies, and it was a little bit lower at 60% in terms of IA2 autoantibodies. But interestingly, not all autoantibodies behaved the same. In the case of GAD autoantibodies, we actually saw the opposite, where there were higher levels of GAD autoantibodies if they were if the blood samples were collected in the evening. So what do we know of these autoantibodies? We know they're involved in type 1 diabetes, but we didn't really know anything about what happens over the course of 24 hours. So here what we've got is just a graph showing the change in autoantibody levels over 24 hours. So let me walk you through this. So here on this line here, we've got how much variation there was in those autoantibody levels. So the higher up this line, the more variability was present in that autoantibody measurement in that individual. And each of these dots represent a different person measured against these antibodies to insulin, GAD, IA2, or the 2 different flavors of ZNTA autoantibodies. So what you can see here is that in those individuals that had insulin autoantibodies or GAD autoantibodies, there's a lot more variation. They're more spread out. And interestingly, their spread in terms of the change is at a higher level than these 3 other types of autoantibodies. So we know that over the course of 24 hours within these individuals, we're seeing a lot of variation in GAD autoantibodies and insulin autoantibodies. And that's reflected by what we call p-values, which is just our way to say, could this have happened by chance? And if the p is less than 0.05, it means that couldn't have happened by chance. It was definitely linked to what we were looking at, which in this case was related to the variation in these autoantibody levels over 24 hours. So knowing that we'd got a lot of variation in these autoantibody levels in some individuals, we wanted to know, does this make a difference to whether someone is classed as being autoantibody positive and therefore at risk of type 1 diabetes, or autoantibody negative, which wouldn't have any risk of developing type 1 diabetes. So here you can see we've taken, in this case, an IA2 autoantibody level, and this donor here is in brown. This is the same person that the blood samples were collected at 9 a.m., 1 p.m., 5 p.m., etc. And you can see that there's this line that this brown line crosses, this dotted line. What does that dotted line actually show you? Sorry. So what it actually shows you is that any time point, there's the circle above that line, we would class this person as being autoantibody positive for IA2. So at 9 a.m., 1 p.m. or 9 p.m., that individual, if that sample was taken at that time, we would say they're positive for IA2 autoantibodies. But interestingly, this person actually dropped below that line. So if that sample was collected instead at 5 p.m., 1 a.m. or 5 a.m., we would class that individual as autoantibody negative. So the time of day that these blood samples are collected actually makes quite a big difference to whether or not we would say this person has this autoantibody and whether or not they would be at risk of developing diabetes. So why is this autoantibody measurement really, really important? And why is it important that we know exactly if someone is at risk or not? So the reason that we care about this time of day really comes to what we're calling preventative therapy. So how can we prevent the development of type 1 diabetes? So in this study that was conducted in the US, we're looking at, in this case, at the percentage of people that didn't have a type 1 diabetes diagnosis. So at the top, this 1 represents 100% of people not having type 1 diabetes. And down at the bottom at 0, it means that everyone would have developed type 1 diabetes. And this is following these individuals so many months after treatment. So it's about 5 years at 60 months. What's interesting is that this treatment that was given only for 2 weeks. And I'll come on to why that's important in a second. But you can see in this brown line, we've got our placebo groups. These are individuals that were at risk of type 1 diabetes. They were identified to have autoantibodies. They were then enrolled into this study and either decided that they were going to receive a placebo, so a control treatment, or they were going to actually receive the actual drug. And interestingly, that actual drug, shown here in blue, is called teplizumab. And what you can see after a 2-week time course, there is still a substantial delay in the development of these individuals receiving this treatment, again, only 2 weeks of treatment, which resulted in a delay in diagnosis in these individuals at risk of type 1 diabetes that had autoantibodies by 2 to 3 years. And this is quite remarkable. This is the only treatment to date that has shown an ability to delay the development of type 1 diabetes. So as you can imagine, this caught the attraction of a number of government agencies, and particularly in America, the FDA, which is just their drug approval authority, it actually agreed that that drug could be used to delay the onset of type 1 diabetes. And in the UK, we've got 2 charities, Breakthrough Type 1 Diabetes and Diabetes UK, both of whom showed that we need to think about how we can make this available to those that might be at risk in the UK. And at the moment, our version of the FDA, our MHRA, has given teplizumab a special status, which means that it could be used in research studies, but it needs a little bit more information before we can actually roll this out to anyone who could be at risk. So we're hoping that by the end of next year, this might be available to those individuals who are at risk of developing type 1 diabetes. But obviously, if we're going to do that, we need to find a way to identify those individuals at risk. So why are we interested in delaying diagnosis, you might ask? Well, it allows us to prepare individuals that might be at risk ahead of their potential diagnosis. And what this means is we could reduce the incidence of some of the life-threatening diabetic ketoacidosis, which is when people that didn't realize they were at risk or even had type 1 come to hospital quite unwell. And this is caused by a lack of insulin because, as Katie mentioned, those immune cells have started to destroy insulin-producing cells, so there's not enough insulin there, which results in the fat in our bodies being broken down into what we call ketone, and they build up in the blood, which causes carbon dioxide to accumulate. So it's very life-threatening if there's not enough insulin in the body. And as I've shown here, about 4% of people with type 1 diabetes experience this a year. So if we can reduce that, that's going to be a huge, make a huge impact into their quality of life. Furthermore, if we can reduce, if we can delay diagnosis, we can reduce how long those people are living with the condition, which can improve their quality of life. It might reduce complications associated with a lifetime of management of diabetes, and also a reduced cost on the NHS. And finally, from our perspective, it gives us more time as researchers to try and intervene to stop diabetes development and to preserve those cells that make insulin that are so important to our body. So as I mentioned, we need to find ways to identify people at risk within the general population. And one way that we're doing this as part of a UK-wide initiative, which Cardiff University is part of, is through this UK Type 1 Diabetes Research Consortium. And we're doing this by looking at individuals in the general population that have autoantibodies. So if you're interested in whether you have autoantibodies that could predispose you to a risk of developing type 1, if you're children between 3 to 13, there's the ELSA study, and that's still recruiting. You can register at this website. Or if you're an adult aged between 18 to 70 and would like to know your risk, you can also register here on this website here. And these websites will be sent to you after the talk in case you're interested. Effectively, how these work, you're sent a blood collection kit to your home address. You can then take your blood sample in a very small tube, and then you can send it back to us. And we'll be able to process that either at our centres in Birmingham or Bristol that are dealing with the processing of those samples. But obviously, we need to identify people at risk. And interestingly, we've got some early data from this TEDRA study, which we're calling the type 1 diabetes risk in adults, that sort of follows suit with the data we've been talking about already. So here, what you can see is the number of participants that have taken part. And here across the bottom, we've got the time of day that they collected that sample. So here we've got midnight to 1 a.m, all the way through in hour intervals to 11 p.m. to midnight. I've highlighted 2 points here. We've got the most people seem to take these blood samples between 11 a.m. and midday. And we see a second wave of individuals taking samples in the early evening between 6 and 7 p.m. So what does this mean in terms of what we've talked about? Well, it means that the majority of people are actually taking blood samples in the evening. And this might actually mean that we're changing what we can detect. So we might be detecting more gyda'r autoantibodies because we know that they're higher in the evening. But it might also mean that we're reducing detection of these other autoantibodies, such as insulin, Z78, and IE2. And that's really important when we think about risk, because as Katie mentioned earlier, the more types of these autoantibodies you have, the greater your risk is to progress to developing type 1 diabetes. So we need accurate detection of all of these autoantibodies to make sure that we're able to give people the right risk of developing type 1 diabetes. So in summary, what we hope to have shown you is that the time of day affects these autoantibody levels that are important for determining risk of developing type 1 diabetes, as well as those individuals that might act positive or negative. And if we're not accurate with saying this individual is positive or negative, it could have implications to whether or not they can take part in a study to receive therapy that could delay development of type 1 diabetes. Obviously, we're quite interested as researchers to understand really what's driving these changes in the immune system that's causing these antibodies to go up and down. And finally, I just kind of wanted to end on what the implications of this research could be. And we've touched on a few of these already, but if we can better identify people at risk of developing type 1 diabetes, it means that more people could receive disease-modifying therapy that could delay the development of type 1 diabetes. It provides more time for people to prepare ahead of diagnosis, so we can help get better infrastructure in place for them to manage their diabetes, to learn more about type 1 diabetes before they get diagnosed. And hopefully the idea would be that we can reduce the risk of those people presenting in hospital with serious complications. And as researchers, it also gives us more time, knowing that we can delay the development of type 1 diabetes for 2.5 years. to actually intervene in different ways to stop the immune system from continuing to cause damage. And obviously, from a research side, we really want to make sure that any future studies take into account the time of day and how that might influence how they design their studies, but also in how they interpret their results. So finally, we'd both like to just thank everyone who's been part of our study. And as always, research is across the world. We've got a number of collaborators that work with us on this project, including those at the University of Bristol, as well as Florida, Indiana, and Western Michigan University. And we'd really like to thank not only our funders, but most importantly, we'd like to thank all the people that took part in this study in the first place. And with that, I think we're very happy to take any questions.
Thank you both. That was fascinating, and I think you presented your work really well and clearly there. So thank you for that. We can now move to the discussion part of the evening and take some questions from the audience. I do have a couple of pre-submitted ones, and I'm going to start with the first, which is, can type 1 diabetes be cured? And a supplementary there, I think you've already shown us we might be able to identify it soon, but can it be prevented if we can predict who is going to develop it?
Yeah, so not at the moment, but we are working on it. As James mentioned with that drug, it was only given for 2 weeks, and then we saw a 2 to 3 year delay. So there could be some sort of change in the dosing or how long we give it for, or even another drug. But there's a lot of research going on sort of behind the scenes and trying to stop it from happening in the place.
And then how about cure? Can we cure type 1 diabetes?
Not yet, unfortunately.
Yeah, I think for a cure, we not only need to target the immune cells that are causing the damage, which is what that drug was doing, but we also need to find a way in those people that have already had damage in replacing those cells that were lost. And that's going to rely on us working with other scientists that work on growing these insulin-making cells to put back into the body. So I think it's going to be a combination process where we target both the immune system and replace what has been lost or damaged, so that if you already have type 1, you could be cured. And if you're at risk, we've already got ways that we can start to sort of delay that process. So there are things coming through. They just have to, they just take a while. But it's a very exciting time to be in the type 1 diabetes research space.
Indeed it is. I'm going to move to the submitted questions now this evening. So we've combined a question here. So do we know why the incidence of diabetes is increasing, and does genetics play a part in whether you are more likely to develop diabetes?
So we know that so Finland has the highest incidence of type 1 diabetes, but then in the neighboring parts of Russia, where they're genetically very similar, they don't have very high levels. So there's loads of different environmental reasons that it could be, because they're quite different lifestyles. But at the moment, we're not quite sure. But I think it's not one thing. It's going to be a combination of different things that is causing this incidence to increase.
Yeah, we know that certainly genetics do play a part, and genetics that play a part are very much linked to how well the immune system works. So it's really clear that we can identify people that might be at a slightly increased risk just based on genetics. But as we've sort of mentioned, that the only real way we know that truly at risk, where we know that the immune system is now causing damage, is those autoantibodies. So that would then take their genetic risk higher, because we know the immune system's misbehaving, it's causing problems. And as Katie mentions, there's a number of environmental factors, from infections to all of these different things that have been examined. And, you know, I think, as Katie said, it's a very complex situation where we know genetics and environmental factors are both involved, but how they play together is a tricky question to try and answer when we're so diverse as people, in really getting a clear answer from that.
Yeah, I get that. I'm a kidney doctor by trade, so the next question is interesting to me as well now. So could the findings of your research be applied to other autoimmune diseases, and if so, which ones?
Yeah, so we know that in rheumatoid arthritis, we know that they've done sort of similar things at looking at when the immune cells peak and when they're at their lowest. And we know for that, early in the morning is when we give the medication for that. That's just because that's when the medication works best with the immune system. But it's not sort of a blanket thing for all autoimmune diseases if it's in the morning or the evening. It's very specific to what's going on and where the damage is occurring.
Yeah, and it certainly is applicable to other autoimmune diseases. There's data coming from something called systemic lupus erythematosus, or SLE, and we know that in that condition, the immune system produces a lot of autoantibodies, and that obviously affects their kidneys and other things. And similar to what we've seen, they actually see that there are time of day changes in how much autoantibodies are being made. So there is potential promise that there could be a similar thing going on with other autoimmune diseases as well.
I mean, a question from me, I guess, now would be, is there any correlation with the variation in the release of insulin through the day compared to when the antibodies might be being produced?
So yeah, we know that from a number of studies going back as far as sort of the early 60s, we knew that insulin is one of those things that our body makes, and it makes it better in the morning when we've slept and we've not eaten food. So you get a large release of insulin at that time, which is why often people recommend having a big breakfast, because your body is best able to process the food at that time, compared to later on in the day when you've eaten your breakfast, your lunch, and your dinner, and your sort of cells that make insulin, they'll still make it, but they'll be a lot more tired. So what we know is that when we look at insulin and relate it to these autoantibody levels, we think in the case of the antibodies that recognize insulin itself, there is some link between those two things. And we're sort of looking at that at the moment, but we can't say the same for the other autoantibodies. So it's something that we're still working on.
Yeah, I struggle to make the link with the other antibodies, and that's yeah, interesting. So moving on. So while you said type 1 diabetes is different to type 2, but could identification of risk and also treatments for type 2 diabetes benefit from your research here into type 1 diabetes? And if so, how?
Yeah. So in the case of type 2 diabetes, it is different to type 1. So type 1, you've got immune system involvement. In type 2 diabetes, there's no immune system involvement. We know that the cells that make insulin, they get a little frustrated. They either don't make enough, or what they do make just doesn't work very well. And sometimes it can be a combination of both of those factors that can lead to type 2 diabetes. We know in type 2 diabetes that if you want to look at the risk of developing type 2 diabetes, specifically looking at germs in our body, we know that the ups and downs that you see in the germs in our tummy, in our intestine, we know that those germs lose their rhythm. We know that goes flat. So, and that's an important way of predicting those individuals who might actually be at risk of developing type 2. So not autoantibodies in type 1, but certainly there's evidence from the germs that live in our bodies that there is a change in those and they lose their rhythms at different times of day. In terms of thinking about therapies, there certainly is some potential. I think for some of the drugs that are out there, they actually sit in the body for a lot longer. So whether we see morning or evening differences, the idea is that we try and maintain levels at a certain amount. So some of those drugs will stay at a good level throughout the day, so they might not have so much of an effect. But if we want to try and boost the amount of insulin that's being made, we know that fasting is very good for that, and that at the morning that's when you're going to have the most release of insulin. So things like lifestyle changes might actually be quite helpful, and there's data that suggests if you condense how long you eat for, so if you, instead of eating, 12 hours a day, you reduce it down to maybe 10 hours or 8 hours from when you start eating to when you finish eating in the day, that actually can be really beneficial to helping lose weight, but also helping with that sort of burden on those cells that make insulin, it gives them more flexibility and more time to rest, which can then boost how well they're working.
Yeah, there's a lot of information in the popular press about this at the moment, isn't there, in terms of the microbiome and gut health. Thank you. Another question, have you had any conversations with clinicians about how in the future your findings may be translated into healthcare services?
Yeah. So we're very lucky at Cardiff. So we work very closely to a number of clinicians in the type 1 diabetes space, particularly Susan Wong and Colin Diane, who lead on a number of clinical trials that have taken place here. So we have spoken to them, and obviously what we're learning here is very important. And with access to both of the screening studies that we've mentioned, both ELSA in children and TEDRA in adults, they're interested. They want to know, when is the best time to measure antibodies from people? When should we recommend that we ask people to take these blood samples in order to get the best result possible so we can get more people receiving preventative therapy? So those conversations have certainly happened. In the terms of other therapies, we're actually in the process of doing a study at the moment related to giving therapy morning and evening. And we're actually looking at what's going to happen and how well those cells respond to therapy. Because if we can get those cells responding better and potentially at a lower dose, it not only means that there's potentially less side effects that people might experience, but also from a finance point of view, if we can use less of that drug, it's actually more, we can save money, which is also really important with the finances, particularly within the NHS, if they want to enroll out this treatment to everyone who could receive it.
Okay, thank you. That's helpful. So you may have answered this one in your last question, but let's try and see where you go with it. The question is, it's wonderful to see the truly international collaboration going on behind your research. In your opinions, what is the one single biggest strength, or it might be two, Cardiff University in particular brings to delivering research like this?
You want to?
Yeah, so I did my undergraduate at the bioscience, so I did biomed, and I chose to do a placement year. So we were really lucky that we have, I think, one of the highest amounts of lab teaching time in bioscience school. They always told us this. So I was a lot more confident in the lab than I think other people were. And then I was supposed to be a placement year student, but then COVID happened. And then I sort of panicked, emailed everyone. And luckily I emailed James and he offered me a position. So I was able to come into the lab, even though it was the pandemic. And from that, I obviously got this PhD, but I've also met so many different researchers and a lot of people on the last slide that we presented all over the world. We actually went to a conference last week, and it was just really nice to be able to see all these people that I've been able to meet, on Zoom from America and everywhere, and Australia. And it's just been really nice. I think it's quite a global place, and it gives a lot more, especially for students. I felt like I was really supported and I wasn't just a statistic or a student number. So I really enjoyed that.
Yeah, and I would add to that, Cardiff have been really supportive in helping us sort of reach out to people. So some people we might not necessarily know straight away, but particularly within the Systems Immunity Research Institute, we're very collaborative. And, if we think that there's someone that we should introduce you to, we will do. So we grow our network quite quickly and able to share and disseminate our findings to a lot of people that are actively really interested in what they're doing. And hopefully, like some of the questions, being able to move what we're doing in type 1 diabetes into other spaces as well.
Yeah, and you mentioned Professors Wong and Diane there, and they've been instrumental, haven't they, really, in terms of Cardiff's reach around the world. So yeah, it's good. So I do have a very technical question for you both now, and I don't know whether you'll be able to answer this, but we'll have a go, and you might need to unpick it a little bit, or I can help you with it. So historically, type 1 diabetes was odd in that it had the reverse social gradient. So perhaps immune modulation by exposure to helminths, etc., and then it just fades at that point. So this comes back a little bit to the gut health, I think, doesn't it? And gut immune modulation. But can you have a stab at trying to interpret that for us, please?
So we know that people who they screened people in Finland that were at risk of developing type 1, and they found that in the gut microbiome of these children, the ones who then went on to develop type 1, the amount of different bacteria in their gut really dropped way before any clinical symptoms. So something's definitely happening with the microbiome. It's not as diverse and full as it is in the people who don't develop the disease, even though they were all at risk. So I think definitely with the helminths, that has a role with the gut microbiome and how they affect that as a whole.
Yeah, it comes down to what we call the hygiene hypothesis. And this is applicable to many autoimmune diseases, where we're living in a cleaner environment now. And Finland is an example in the case of type 1 diabetes where it is cleaner. And what that means is we're not exposed to the same germs that we would have been exposed to. And that actually can be detrimental in some respects to how your immune system works, because it doesn't have that same education. It's not exposed to so many germs to educate it. And what that means is that your immune system in some individuals that are at risk, it means that their immune system starts, if you like, misbehaving because it thinks it needs to do something, but it's not sure what it needs to do. So then it starts turning on itself and attacking different parts of the body. So this is common across all autoimmune diseases. So obviously there are strategies, and this is where, you know, the germs and the microbiome come in, where we can try and think of ways that we can use that to our advantage to try and re-educate the immune system so that we can say, you know, we're going to give you exposures to safe germs in the hope that you don't get bored and start attacking your own body. And there's definitely evidence, particularly in Australia, where vaccines to viruses in the gut, what we call enteroviruses, have actually reduced the incidence of type 1 diabetes. So, you know, there are some interesting links at the moment to what we could do as a preventative strategy as well.
Thank you both. I mean, that has been a fascinating walk through this subject area. And I think you've both demonstrated the in-depth knowledge and the strength of your the work that you're doing really to move this forward. Unfortunately, we are out of time today. I would like to thank you both, big diolch to James and Katie. Thank you very much for your presentations and discussions and taking the time to do this. As we've pointed out, this is really important to us in terms of being able to show exactly what we can do as a university here and contribute to some of the most important challenges that the health service has to deal with and people have to deal with. So thank you very much. I'm also going to thank our webinar audience for being with us. I hope you found it interesting. Certainly I've learned a lot today that might well be applicable to some of my own clinical practice. If we didn't get a chance to answer your question, we will follow up with you directly, and you will receive an email in the next few days with a link to this recording and links to register for future events. I've done a few of these now, and they are fascinating learning opportunities. We've got more of our research showcase events coming up in the new year, so you're all very, very welcome to those. If you'd like to get involved with Cardiff University, volunteering time to help our students or helping us to fundraise for our research, then please follow the link in the comments box that is on the screen now. And from myself, James, Katie, and the rest of the team that's put this webinar together for you, diolch yn fawr, thank you and good evening.